You know that feeling, right? It's 2 in the morning, you have some weird symptom, and you start typing it into a search bar. We've all done it. But what's changing is that now, instead of just getting a terrifying list of links, you can have a whole conversation with an AI about it. So let's get into it, because AI is quickly becoming the new corner pharmacist for millions of us, and it's completely changing how we think about our own health. And look, this is a serious question. We're not talking about just looking up the side effects of a pill anymore. We're talking about people getting detailed, personalized health advice from these huge AI models. And this isn't some science fiction future. It's happening right now on a massive scale. And that really is the multi-billion-dollar question, isn't it? When you go from asking an AI, hey, what's the capital of Nebraska, to what's this weird rash on my arm, the stakes get, well, they get infinitely higher. So can we actually trust these incredibly powerful systems with something as important as our health? So yeah, welcome to the age of Dr. GPT. It's a pretty catchy name for a really huge shift in how we look for information. People are skipping the old search engines and going straight to these conversational AIs, treating them like a personal doctor who's on call 24/7. And this isn't just a few tech nerds doing this. To really get a handle on how well these AIs are performing, researchers recently reviewed not one or two, but 60 different studies on the topic. And get this, all of them were published in just the first 5 months of 2023. That's just wild. It shows you how incredibly fast this whole field is moving. And just check out the sheer range of medical fields they're testing this stuff in. We're seeing AI advice get put under the microscope for everything from internal medicine and surgery to super specialized fields like ophthalmology. This goes way beyond general wellness tips. Okay, so how on earth are these everyday consumer tools able to have such sophisticated conversations about our health? Well, it's because the technology running them is now way, way more advanced than a simple keyword search. You see, today's AI systems use this powerful mix of technologies. It's not just about matching the exact words you type in. That's old school full text search. Now it's all about semantic search, which is just a fancy way of saying the AI actually understands the meaning and the context of what you're asking. You combine that with some really advanced ways of storing data, and you get these incredibly relevant, human-like answers in seconds. All right, and this brings us to what is maybe the most crucial distinction in this whole conversation. The AI you chat with online feels like this super knowledgeable, helpful friend. But there is a massive, regulated chasm between a helpful friend and a licensed medical professional, or in this case, a certified medical device. Let's dig into what that difference really looks like. Because the second an AI tool is meant to be used for actual medical purposes, like diagnosing, treating, or preventing a disease, it steps into a totally different world. It's a world governed by really strict rules, like the ones from the US Food and Drug Administration, the FDA. The game just completely changes. You see, the FDA doesn't just give an AI tool a thumbs up and then walk away. They manage it using a framework called the total product lifecycle. This means that AI is under an intense microscope from the moment it's just an idea all the way through development and for its entire life out in the real world. It's a nonstop commitment to making sure it's safe and effective. This quote right here, this is the heart of the whole thing. This is the FDA's actual definition of validation. Notice the words they use: objective evidence, specific intended use, and consistently fulfilled. This isn't about giving a pretty good answer most of the time. It's about proving with cold, hard data that the AI can do its very specific job reliably, every single time. So this whole TLPC approach is a super rigorous process. You've got the development phase, then that intense validation we just talked about. After that, you have to clearly describe what the final device is and what it does. And it doesn't just stop there. There's ongoing management and cybersecurity monitoring after it's been released. It really never ends. And here's something you might not have thought about. For a medical AI, the dangers go so far beyond just giving you a wrong answer. Because it's a learning system, it's vulnerable to a whole new class of cyber threats that can basically corrupt it from the inside out. Regulators are worried about these brand new kinds of attacks, things like data poisoning, where someone could maliciously feed the AI bad data to make it unreliable, or model evasion, where someone figures out how to craft a question in just the right way to trick the AI. These are really sophisticated attacks that your average consumer AI just isn't built to defend against. Okay, so if the risks are this high and the standards are this demanding, how do you actually build an AI that a doctor or a regulator can trust? You can't just pop the hood on a neural network and see how it's thinking.
You need a totally new way to show what's going on inside.
So how do you do it? How do you make this so-called black box transparent enough for someone to feel comfortable betting a patient's health on it? Well, the answer is actually pretty brilliant, and it's elegantly simple. You create a kind of nutrition label, but for the algorithm.
And this is basically it. It's called a model card. And this is the kind of thing the FDA recommends. It's just a clear, simple summary that tells you exactly what the AI is supposed to do, who it's for, what its known limitations are, the data it was trained on, and, this is the big one, how it actually performed in real-world tests.
And this is where all those performance numbers stop being abstract and start feeling real. This diagram shows you what would happen if you used this hypothetical medical AI on 1,000 patients. You can literally see the flow, how many people are correctly identified as having a disease, and just as critically, how many are wrongly flagged. You see the false positives and the false negatives. The FDA even suggests putting this data into plain language, and this is a perfect example. It translates all that complex math into one simple, powerful trade-off. To find one person who's actually sick, this system will incorrectly flag almost one healthy person. Now, is that an acceptable trade-off? That's the kind of critical question this transparency allows everyone to ask.
And this leads to one of the most important questions you can ask about any AI system. An overall accuracy number can be really misleading. A model could be 95% accurate on average, but what if it's dangerously inaccurate for a specific group of people?
That's exactly why the FDA requires performance to be broken down across different demographic groups. In this example data, you can see the model's sensitivity for white patients is 85.3%, but for Black or African American patients, it's a little lower, at 82.9%. Performance also dips a bit for patients over 79. Now, these aren't huge gaps, but they are real, and they absolutely must be identified, measured, and disclosed.
So let's just put it all side by side. On one hand, you have consumer AI. It's largely unregulated, its performance is a mystery, it's built for general use, and it's trained on who knows what data from the internet. On the other hand, you have a medical device AI. It's got direct FDA oversight, its performance is transparent through a model card, it's built for one specific job, and it's trained on carefully vetted data. They are truly two completely different worlds.
So, after all that, what does this actually mean for you? For the person who just wants to understand a symptom and figure out what to do next? Well, it means understanding exactly what kind of tool you're using and which of those two worlds it comes from. At the end of the day, the Dr. GPT in your web browser and the FDA-approved AI in a hospital are both getting smarter and fast. The underlying technology is converging, but the process, the accountability, and the standards of trust remain worlds apart. And the biggest challenge for all of us is going to be navigating that difference. So the question is, who or what will you choose to trust?